This is a recast of the 7,400-word piece, Symbolic versus Subsymbolic AI from GPT-5. This article explores the strengths and weaknesses of two AI approaches, symbolic and subsumption, and discusses their implications for the field of artificial intelligence. Let's listen in.
Artificial intelligence, AI, is often divided into two main categories, symbolic and subsumption. Symbolic AI involves the use of formal logic and rule-based systems to represent knowledge and make decisions, while subsumption AI uses machine learning to develop intelligent behaviors based on patterns and statistical analysis. These two approaches to AI have fundamentally different approaches to representing the world, learning, and problem-solving, leading to ongoing debates about which approach is superior. Today, we're going to explore the strengths and weaknesses of each approach.
Starting with a brief overview of the two models and their theoretical basis. Symbolic AI, also known as rule-based AI, is an approach to artificial intelligence that involves the use of symbols to represent concepts for the purpose of performing logical operations and manipulating knowledge. Symbolic AI is based on formal logic and rule-based systems, making it suitable for expert systems and applications that rely on logical thinking. Subsumption AI, also known as connectionist AI, on the other hand, is an approach that uses neural networks and other techniques of machine learning to simulate the functioning of biological neurons.
The resulting system can learn and adapt to new situations without being explicitly programmed. In this article, we will be looking at a comparative analysis of symbolic and subsumption AI. We'll start with a comparison of the strengths and limitations of each model and their respective applications in different areas. Then we'll examine the potential for hybrid models that combine symbolic and subsumption approaches to AI and consider the associated benefits and challenges.
Finally, this comparative analysis will shed light on the ongoing debate between symbolic and subsumption AI and its implications for the field of artificial intelligence. One key disadvantage of symbolic AI is its inability to process large amounts of data. Since symbolic AI is based on predefined rules and logical structures, it has difficulty processing large datasets. In contrast, subsumption AI is able to process massive datasets and extract meaningful patterns through machine learning and neural networks. This ability to access large datasets is an important advantage of subsumption AI over symbolic AI.
Symbolic AI refers to the use of symbols and rules for representing and manipulating knowledge. The symbolic approach is mainly based on logic and linguistics. It involves building knowledge-based systems that use logical thinking to draw conclusions based on a set of premises. Symbolic AI systems are good at representing objects and concepts in the world and reasoning about them. They are often used in expert systems, natural language processing, and intelligent learning systems. The main issue with this approach is the difficulty of representing knowledge that is ambiguous or context-dependent.
Symbolic AI, also known as rule-based AI or logic-based AI, is a type of artificial intelligence that uses logical rules and symbolic representation to solve problems and make decisions. Symbolic AI systems represent knowledge and information using symbols such as words, numbers, and icons, using logical inference and deduction to derive new knowledge and solve problems. Symbolic AI is well suited for problems involving complex logic, planning and decision-making such as expert systems, natural language processing, cognitive modeling.
Symbolical AI relies on the assumption that complex logic can be achieved by manipulating symbols and applying predetermined rules. The key features of symbolic AI include its ability to represent knowledge and draw inferences from it, create plans or goals, and think structuredly about uncertainty and ambiguity. Symbolical AI is also highly interpretable, meaning that its thought processes and decisions can be understood by humans. However, symbolical AI may have difficulty dealing with large datasets, making it less effective in tasks such as image or speech recognition.
Now let's talk about subsymbolic AI. Subsymbolic AI, also referred to as connectionist AI or neural networks, is an approach to artificial intelligence that focuses on creating models that serve as simplified versions of the workings of the human brain. This involves the creation of artificial neural networks, which consist of interconnected nodes that simulate the workings of neurons in the brain. By analyzing data and adjusting the weights of the network, subsymbolic AI models can learn to recognize patterns and make predictions, similar to how the brain processes information.
Examples of applications of subsymbolic AI include speech recognition systems, image recognition systems, and self-driving cars. However, these systems have limitations in their ability to explain their decisions, which can lead to concerns regarding transparency, accountability, and possible bias. Additionally, subsymbolic AI requires large datasets and computing power, making its implementation difficult in resource-restricted environments.
One of the advantages of the subsymbolic approach is its ability to process large datasets quickly and accurately. This is particularly useful in areas such as image recognition and natural language processing. Unlike symbolic AI, subsymbolic AI relies on neural networks that can learn from large datasets and adapt to new information, making them highly flexible and applicable in various contexts.
A notable aspect of subsymbolic AI systems is their ability to learn and adapt to changing environments, which makes them highly flexible and applicable in various contexts. Subsymbolic AI techniques are based on neural networks and machine learning algorithms to create intelligent applications that can learn with experience and improve themselves. Examples of applications of subsymbolic AI include speech recognition systems, image recognition systems, and self-driving cars. However, these systems have limitations in their ability to explain their decisions, which can lead to concerns regarding transparency, accountability, and possible bias.
In conclusion, symbolic AI and subsymbolic AI are two essential approaches to AI that differ in how they represent and process information. Symbolic AI is based on explicit representations of knowledge and inferences, and is well suited for areas requiring logic, planning, and natural language processing. Subsymbolic AI, on the other hand, is based on distributed representations and is better suited for tasks involving pattern recognition, learning, and optimization. Both approaches have their strengths and weaknesses, and researchers are constantly exploring ways to combine them for better AI systems.
Furthermore, one of the major ethical implications of AI is its potential to be used for negative purposes. Given the power and autonomy of AI systems, it is important for policymakers and developers to consider the potential pitfalls of AI and create safeguards to prevent malicious use.
In addition, the impact of AI on the future of work is an area of concern. Automation and AI could potentially replace or displace millions of jobs, leading to higher unemployment and a widening of the gap between the rich and the poor. On the other hand, AI could also create new jobs and opportunities that leverage human capabilities that machines cannot replicate.
Overall, the implications of AI are far-reaching and profound. The future of AI will depend on our ability to manage its progress in a responsible and ethical manner. With careful planning and collaboration between researchers, policymakers, and industry, we have the opportunity to create a future in which AI can be used to benefit society.